Hi folks, welcome back to the last video in 9.5 matrices and matrix operations. And so in this video, we're going to do the thing that I think is the most challenging for folks, which is matrix multiplication, okay? So we're going to start off with what we cannot do. So let's say we have a 2 by 2 and a 2 by 2, all right? We cannot just say, oh, 4 times 5 will give us 20. And then 1 times 8 will give us 8. And 3 times 6, which is 3 times 6, gives us 18. And 2 times 7, or 2 times 7, gives us 14. Okay? So I want to just reiterate that we cannot, let's make sure we cannot do this, okay? So do not do this, all right? I will be very, very sad if I see your paper and you just multiply each of the entries together, okay? However, this is the process that we use when we're multiplying matrices, okay? We take the entries in the first row of the first matrix and the first column of the second matrix, okay? And then we multiply the first in the first, and then the second in the row with the second in the column, and we add them together, okay? Then we find the second row and the first column to give us the entry in the second row, first column. Then we take the first row and the second column to find the entry in the first row and the second column. And lastly, we take the second row and the second column to get the entry in the second row and the second column, okay? It looks a little bit like the dot product, okay? Looks a little bit like the dot product, except it's really important that we make sure certain things match, okay? So it turns out we can only multiply matrices when the inner dimensions are equal to each other, right? So what do I mean by inner dimensions? Let's go back to sort of the idea from the first video. We know that this is a 2 row by 2 column, and so is the second one, 2 row by 2 column. So when I say that the inner matrices need to match, what I mean is these two numbers, the columns of the first matrix and the rows of the second matrix, those need to be equal. If those are equal, we're good to go. If they're not equal, we can't do anything more, okay? So let's practice this technique a bunch. All right, so we have A, B, and C. And what I'm going to do before anything else is write out the dimensions of these matrices. Because once I have the dimensions, that will tell me, can I actually multiply them or not? Okay, so A has 2 rows and 3 columns. B has 3 rows and 2 columns, and C has 3 rows and 3 columns, okay? So, for example, I could multiply A and B because the 3 and the 3 match, all right? But could I do B times C? Well, this 2 is not equal to the 3. So if I see B times C, I can already say, I can't do that one, okay? All right, so let's get started. AB, let's write it out, means we take our A matrix, -1, 2, 3, end for 0, 5, and we multiply it by the B matrix, which is 5, -4, 2, and -1, 0, and 3. Okay, now I know this is a 2 by 3 times a 3 by 2. And because the inner dimensions are equal to each other, we can proceed. I wonder how large the final matrix is going to be. And I bet some of these numbers in here will actually tell us. Okay, so let's go through our process, see how big our resulting matrix is, and see if we can figure out a pattern from the numbers that it tells us. Okay. All right, so I'm going to leave myself plenty of space here. I've got -1 times 5 plus 2 times -4 plus 3 times 2. So that's all of the entries from the first row times all of the entries in the second matrix in the first column, and then adding those together. Okay. All right, well, now to find this entry, I can take the second row and the first column and do sort of the similar thing. So 4 times 5 plus 0 times -4 plus 5 times 2. Okay. Now, I don't have any more because I don't have any more rows from the first matrix. Okay. So what about the other entries? Well, now I have to do the first row times the second column. All right, so let's see what that looks like. So for a separate entry, we have the first row times the second column. So first row times second column plus first row times second column. All right. And then to get what I think is going to be the last entries, I take the second row, second column, multiply them out. Okay, so second row, 4 times -1 plus 0 times 0 plus 5 times 3. Okay. Now check this out. I started with a 2 by 3 times a 3 by 2. And as we mentioned above, if these are the same, we're good to go. But the rows in the first matrix and the columns of the second matrix actually tell us the dimensions of our final answer. All right. So even though I haven't simplified any numbers here, I'm going to have one number here, one number here, one number here, and one number here. Okay. I'm going to have 4 numbers. I'm in fact going to have a 4 by 4 a 2 by 2 matrix. All right. So let's find out what those entries are. I have -1 times 5. All right. So -1 times 5 is -5. -8 plus 6 is going to give me -7 for that first entry. All right, what about below that? 4 times 5 is 20 plus 0 plus 10 is going to give us 30. Okay. What about over here? Well, I've got 1 plus 0 plus 9, which will give me 10. And then -4 plus 15 is going to give me 11. And so I see here that my answer is actually a 2 by 2 matrix. Okay. So when we're multiplying matrices, write out the dimensions first. You want to make sure that these inner ones match. That means we can do it, but the outer dimensions actually tell you how big your final answer is going to be. Okay, so you kind of know when to start and when to stop. All right. Let's do the same thing for part B. So you'll notice that A says A times B and B says B times A. So really what I'm trying to ask us to see here is matrix multiplication commutative? Kind of like I did in the second video where I had A plus B times A minus B, or A minus B, right? So the order didn't matter. It turns out for addition and subtraction, it didn't matter. I wonder about multiplication, okay? So let's copy down our matrices. Let's see what we get. So B is our 5, -4, and 2, -1, 0, and 3. And this is a 3 by 2. And I'm multiplying it by A, -1, 2, 3, 4, 0, 5, which is a 2 by 3. Now I see that the inner dimensions match. That means I can proceed. But how large is my answer going to be? It's going to be a 3 by 3. So I almost already have my answer. When I multiplied A times B, I got a 2 by 2. But when I multiply B times A, I get a 3 by 3. That means the matrix multiplication is not commutative. Okay, so maybe that's a note we leave for ourselves. Matrix multiplication is not commutative. I cannot change the order and get the same thing. Okay. All right, so let's work through our numbers here. I'll make this one a little bit bigger because I know I'm going to have 3 rows and 3 columns. So 5 times -1 plus -1 times 4. And then -4 times -1 plus 0 times 4. And then this one will be 2 times -1 plus 3 times 4. I guess I made that a little bit too big. That's okay. Okay, so that was the first row. Sorry, the first row times the first column. Now I need to find the second row times there. That gives me this entry. And then finally, the third row times the first column gave me down here. Okay, now we're going to work our way across. So first row times second column. All right, and let's see what that gets us. First row times the second column. So that's going to be 5 times 2 plus -1 times 0. Okay, so I took the first row and the second column. Now I'm going to take the second row and the second column. So -4 times 2 plus 0 times 0. And finally, I'm going to take the third row and the second column. So that'll give me 2 times 2 plus 3 times 0. Okay, now, beauty of the tablet, I'm going to shrink this in a little bit to give myself enough room for the last one, which will be first row, third column. Second row, third column. Third row, third column. Okay, so 5 times 3 plus -1 times 5. 5, nope. -4 times 3 plus 0 times 5. And then finally, 2 times 3 plus 3 times 5. Okay. Whew. So this is the kind of work that I do want to see on your quizzes. All right. So please make sure that you show your thinking here. But ultimately, we should end up with a 3 by 3 matrix. All right. So -5 plus -4 is -9. 4 plus 0 is 4. -2 plus 12 is 10. All right. 5 times 2 is 10. -8. and 4. And last but not least, 15 minus 5 is 10, negative 12, and 6 plus 15 is 21. All right. Do I have a 3 by 3 matrix at the end? I sure do. And we knew that from the beginning because we had seen that the outer dimensions are 3 by 3. Okay. All right. So here's what we're going to do. We're going to go ahead and leave the rest as extra practice for you, okay? There are many matrix calculators online, so you can check your answers, but take the time to work through this process, but also to set things up, because even though I gave us 4 examples here, I'm going to claim that some of them we can't even do. All right, so you don't really have 4 that you need to do all the computation for. You have 4 that you need to figure out, A, can I do them? Because if you can't, then you just write no solution. And B, if I can do them, can I practice my arithmetic? Okay, so I'll leave it here for you. Feel free to stop by office hours if you have any questions about your solutions here, and have a great rest of your day.